All right, ladies and gentlemen, my name is Glenn Sizemore. I am a senior technical marketing architect here at VMware in our storage and availability business unit, and I am responsible for all things storage in the VMware Cloud on AWS service. My partner in crime is on his way right now to Bulgaria to meet with the development team responsible for site recovery, so I'm going to fill in for Cato today and represent what we have to offer with our disaster recovery as a service offering, which is powered by VMware Site Recovery. Before I get too far into this, though, I'd just like to level set a little bit. We have an opinion here inside VMware, that the current state of the disaster recovery market is unsatisfactory, right? There are problems in the way that we are currently addressing the solution. We break this down into three big categories. The first one is business risk. Most companies that have a DR solution, it's not complete. If they have anything at all, it typically just covers their tier 1 applications and they're exposed in 2 and 3. They don't have a holistic approach to disaster recovery, so there's a lot of gaps. Those gaps are largely drawn or caused by the complexity that exists inside these existing solutions. For a large part, although this is getting better as cloud partners come online to offload the challenge, but traditionally, customers were asked to worry about all the above, right? They had to manage multiple sites, and then there's complexity in running the second site. You have to keep them synchronized. If I make a change in the first one, is that going to break my disaster in the second one? The reality of maintaining these operations and then being able to manage it and test it so that you have confidence in it in the event that you need it, it's a challenge. So how does site recovery solve this challenge for us? Well, it does it in a couple of ways. The first of which is that it accelerates our time to protection. By making it an add-on inside the VMware Cloud on AWS service, all you have to do is go into any available SDDC and just click Activate on that site recovery add-on, and we'll automatically go in and deploy the components for you, and then give you a download link where you can download the on-site VR components yourself. This, of course, enables us to accelerate that time to protection. We like to say you can go from 0 to DR in about an hour if you have an existing SDDC, because that's about how long it takes for us to fully install, configure, and then get vSphere replication copies running to protect the underlying data. This, of course, enables organizations to dramatically simplify their recovery operations, because it's all cloud hosted and inside a service. Right? Your recovery site is being managed by VMware. You don't have to think about it. It's going to be there. It's going to work. We're also managing your recovery platform, right, in the site recovery software. We keep it up to date. We keep it upgraded for you. Because it's all integrated, it also provides some operational simplicity just from a manageability perspective. As we'll see in the demo I'm going to get into in a minute, this is all VMware, and it's very obviously VMware. It's all very integrated from a client perspective. And then finally, because we're sitting inside the VMware Cloud on AWS service, we get to leverage those cloud economics, right? We get to leverage that scalability on demand as needed. Go ahead and burst up and down with workloads, leveraging that elasticity inside AWS. Again, all of this is built and delivered as a managed add-on on top of the service, and it's for those of you who are familiar with the product, it's Site Recovery, right? This is Site Recovery Manager. The reason we call it VMware Site Recovery instead of Site Recovery Manager is because it's a service. We're taking the same product that you already know, we're taking the same platform and solutions that are trusted around the globe, and we're just producing it as a service, reducing the administrative overhead and the ask from the customer side. Yes?
Part of AWS's recommendations for highly available is not only using multiple availability zones, but also multiple regions. I see that this is mostly, like they had bidirectional in your last slide between availability zones, but is this something that VMware is looking toward maybe to allow that failover into another region, perhaps?
From a site recovery perspective, absolutely. And that we have full fan-in, fan-out capability. So we can take multiple on-premises organizations and fail them into a single location, and or conversely, we could take a single SDDC and replicate it out to multiple physicals, or we could go from SDDC to SDDC. It's site recovery, right? All the flexibility and options that you're used to are there, with one exception. We don't currently support site array adapters. So there's no way for us to get third-party storage into SRM today, right? Because we don't have those SRAs. Okay, yes?
So the cost of these environments is non-trivial, right? So what does a customer do if they have multiple environments that they need to protect? What are their options?
Great question. Let me show you. So here we have, oh, what? Why is that there? Oh, no. Oh, no. Okay, this is going to be harder than I thought it was going to be. Wait, what about? Okay, no, that works. Okay, so as you can see, I'm already logged into my VMware Cloud on AWS SDDC. This SDDC has multiple clusters. Now, the demo I'm about to show you is protecting multiple sites using multiple clusters. So cluster 1 is protecting one site, cluster 2 is protecting another site. In this case, that was just what made sense because of the resource utilization. This cluster is using a combination. We can see here we've got our i3 metal hosts. I can tell because of the capacity. And then over here, I've got R5 metal hosts. I can tell, again, because of the capacity. If we wanted to, though, we could have a single SDDC that was protecting multiple sites, right? We could fan in, absolutely. So if I have 50 sites around the globe and I want to put a single SDDC at roughly the equivalent middle point of all of them, replicate all of it in. It's not a problem, as long as we do have some restrictions as to the number of VMs we can protect per vSphere replication instance, as well as per SRM instance, but we can install multiple instances on top of a single SDDC.
So if we extend this a bit, can we also provide a third site to a stretch cluster scenario?
Yes. Yeah, well, you could be running a stretch cluster on premises, you could run a stretch cluster in the cloud, and you could have SRM replicating between them if you really want to set the availability to 11.
Is there any consideration for a kind of pilot-like deployment where I could have that like single host in VMware Cloud and AWS I'm replicating to?
Yeah, we touched on this a little bit this morning. Currently, our pilot light is 3 hosts. Right. We have some plans. We're looking at ways that we could offload that, particularly try to go to a maybe even 0 host option. Who knows, right? But today it's 3 hosts. We need to have the cluster up and available. Okay. So real quick, let's just get in here and I'll try to walk through a full product demo. So when we log in here, the first thing that I'll draw your attention to, I logged into my cloud portal, right? But you'll notice that I've got 2 virtual centers here. That's because we've configured that hybrid link mode in this environment. So when I log into that cloud-hosted virtual center instance, I'm automatically connected and I have visibility into my on-premises instances. So here we can see we've got a 10-host vSAN vSphere cluster with right at 560 virtual machines running on top of it. We also see we've got this secondary data center running in Tokyo with a number 500 some odd virtual machines running on top of another 10-host cluster. Now, if we take a look at those cloud-hosted SDDC instances, we can see that we have that first cluster 1, 3-host cluster, protecting those 500 some odd virtual machines. We can tell that they're being protected. There's a couple of visual cues here if you know what you're looking for. We can see all of our various virtual machines. Our placeholder objects for that SRM failover are available inside the environment. We can tell that because we've got these 3 little dots on each one of our VM notifications. Now, if we take a look at cluster 2 is acting as the recovery site for our Tokyo operations, right? So we've got 2 different sides of the world. We've got a data center roughly in the middle in Oregon, and they're both replicating into that common protection point. So now what I'll do is I'll go back into cluster 1 and we'll take a look at this environment. Okay, so go figure. We're in a disaster demo and a disaster occurs. Who would have thunk it? Now what we could do in this moment, right, because it had just appeared that our entire business died. The main cluster that everything runs out of our New York main operations center is hard down, or at least from what we can see, it's hard down. We don't have any additional visibility. Now we could panic. We could run around and try to figure out how to fix this. But instead, we're just going to go ahead and open up that site recovery panel because we preemptively thought through this and we took care of ourselves and we've configured site recovery ahead of time. Now, when I open up that site recovery panel, I can see that I have a site pair, which is linking that on-premises virtual center to my cloud-hosted virtual center. We can see that I have about 1,000 virtual machines currently protected inside this environment over a pair of recovery plans. If I go in and take a look at the portal, what I see is that the individual virtual machines, when I log into the portal, the underlying vSphere replication relationships are reporting up as a problem, right? So vSphere Replica is reporting up through the VMware Site Recovery panel that it is having a problem getting to New York. So double verification that a problem has occurred. Both Virtual Center can't talk to the hosts, and vSphere replication can't talk to its replication partner. At this point in time, we feel safe. We are in a disaster. We do need to get things back. So we're going to go ahead and open up this recovery plan that we've configured ahead of time, which protects all of the New York operations. As we can see right at 559 virtual machines. And we can also see that a test has reasonably recently been ran. So there's a high degree of confidence that this is going to actually be successful. So we'll go ahead and we'll just run that recovery plan right away. We won't waste any time. Let's get the business back. We need to acknowledge that this is going to be a disruptive activity. And then we need to tell Site Recovery what kind of failover we'd like to perform. By default, Site Recovery does not want to lose any transactions or any data, right? So it needs to go through a fairly formal shutdown and synchronization phase. And if we cannot complete that synchronization phase, we abort the failover. Since the New York site is not available, we're not going to be able to do that, right? So instead, what I'm going to do is I'm going to tell Site Recovery that this is a disaster recovery, which is going to let it know that we want it to succeed. It doesn't matter what failures you encounter. Just get the business back, get these workloads powered back on. Let's hit finish on this. And now Site Recovery kicks off its activities. In the interest of your time, we've sped this up a little bit. This takes 25 minutes in the real world for us to actually recover all 559 virtual machines. As you can see, as I mentioned, the pre-synchronization and shutdown phases were not successful because, of course, New York is not manageable at this time. But we were able to power on all those various virtual machines. So now if I hop back up and take a look at our cloud console, of course, New York is still powered down. But if we take a look at that cloud-hosted SDDC, we can see that all those virtual machines have now been powered up. So we've brought those resources online. You may also notice that there's a couple more hosts in here than the last time we visited. And if we expand the tasks view here, we can actually see that this .78 host is actively in the process of being added. Now, if I come back out to my cloud portal, what I'll discover is we're actually scaling this SDDC right now. This SDDC is going through a scaling operation. Now, the way that this was caused or triggered, one of the very first things that happened is there's an IT VM in that first recovery group. When it powered on, it looked at VMware tools to figure out where it was running, and when it discovered it was running inside Amazon, it knew that it was part of a disaster. So it preemptively called out to our public API, which it was able to get to because it wasn't on a bubble network, and triggered a scale-up activity for us. Right? So this is going to bring our cluster up to what we perceive to be the production run point. So the 3 hosts is our pilot light. That's what we need from a storage perspective. In this instance, we think we need about 8 from a compute and memory perspective. Question?
That VM that got fired up, that's something that you guys manage, not the customer? Okay.
Yeah. No, we don't manage that. Sorry. In this case, it's an example of how a customer can leverage the the SDK of the service to programmatically scale their resources if they so choose. Now, if they don't want to do it manually, they can use a feature that we're also leveraging here, Elastic DRaaS. But the challenge with Elastic DRaaS and using it for DR scaling is that double host scaling limitation, right? We're only going to add 2 and then we pause for a little bit.
Right.
So if we want to add 6 or 8 hosts at a time, we need to do that either manually or through the API. But we can script it, we can programmatic, so remove the human elements so that it's automated and part of the failover. And the reality is, a real recovery plan almost always has a little bit of automation in the baseline that has to reach out and talk and coordinate some other things. Because the whole business doesn't reside inside vSphere, although we'd welcome you to do that.
Are those scripts to do that published on GitHub somewhere, or?
Not yet, although I'm working with Cato to get some public examples out there to accelerate this for customers who want to leverage and copy what we did for this demo.
Okay. Second question.
Sure.
In terms of sizing for connectivity between your on-premises environment and the SDDC that's in AWS, do you have sizing guides for what sort of pipe you should have, latency, all that kind of stuff?
We're not so sensitive on the latency side because it is asynchronous replication, but we do have throughput calculations. That's all public. So this is largely one of the advantages of being based on a well-established product, right? vSphere replication is something that a lot of people are already experts on. If you'd like the tooling already exists for us to figure out how much throughput it would take for us to maintain a given availability point. And this is where the 1-2 punch of our flexibility combined with the AWS cloud really starts to come in. Because if a customer needs significant bandwidth, we can provide that through AWS Direct Connect and various other options to get fat pipes up into these SDDCs for massive synchronization. Yes?
So in the demo here, we've experienced site loss, and we're recovering in our cloud-hosted SDDC. What kind of data loss can we expect from the time that event occurred to the time we bring those workloads up in VMC?
Yeah, so in this case, right, since we triggered a disaster failover, anything that happened from the last time that VM did its synchronization through vSphere replication to the moment that we clicked failover is gone, right? And that's the catch with a disaster failover. You are accepting transaction loss because you are choosing to power on what you have irregardless of what may exist on premises at that point in time or on the protected site.
But what are the configurable ranges for that? How close to zero is this product capable of getting?
I want to say that our tightest replication window is 5 minutes, but it may be 15. For some reason, those two numbers are bouncing in my head, and I can't get it straight.
I don't know in VMware Cloud and AWS, but when you have vSphere replication on top of vSAN, then you can go as low as 5 minutes.
Yeah, so it's 5 minutes then, because it's the same. It's the same exact product. It's just we're installing it, patching it, managing it on your behalf, but the underlying bits are the same.
And there are efforts ongoing to continuously improve that and bring that down?
I don't know how much lower than 5 minutes realistically we're going to be able to bend that curve, but if customers give us a realistic reason to push it, then absolutely. You know, the reality that even in massive storage use cases, if you need an SLA lower than 5 minutes, right, we're not talking about regional availability most of the time unless we get application specific. You almost have to get at the app layer to get that level of availability.
Well, why aren't we talking about continuous data protection instead of snapshots here?
Well, so this isn't snapshots, right? It's replicated in Windows. And the reason we're talking about it is because of scale. If you want to do continuous data protection on 10 VMs, all good. You want to do continuous data protection on 5,000, it's not going to happen. So it's just, it's a reality of, look, if you go to the business and say, how much data can we lose? Their answer is always 0. When you show them the price tag for 0, all of a sudden they find loss. It's like, well, maybe 15 minutes is okay. Speaking of which, and this gets back to our earlier conversation around the elastic DRaaS, you can see here that we've defined a financial bounds, right? So we've said that this particular SDDC can scale from 3 to 10 hosts. And in this case, we automatically scaled it up to 8. So if it turns out that 8 wasn't quite enough, right, if we undershot that number and the resources are pounding the cluster a little heavy, then Elastic DRaaS is going to bail us out. It's just going to go ahead and it'll scale us up all the way up to 10. If we were a little bit too aggressive and we've got too much resources in there, here in about an hour it'll come in and it'll start pulling hosts back out. Okay, so these two combined really empower customers to control a production-ready disaster recovery option and really control their costs in a lot of different elements, right? We can minimize the initial online footprint that you have to keep powered on to the bare minimum from a storage footprint, and then leverage that elasticity automatically and then guarantee that we're going to keep that in line and we're not going to be consuming a bunch of resources that we don't require. So now if we go back into Virtual Center and take a look at this environment, again, now that we're done scaling up, we can see that our cluster is nice and healthy. Our workloads are up and running. But it looks like that New York site is back online. I've got a warning up here. And in fact, yep, my hosts are available. But unfortunately, it looks like we're in the middle of that dreaded scenario where the site that failed didn't really fail. It was just disconnected for a little while. Right? And why do we know that? Well, our VMs are still powered on. Right? So the hosts never actually went totally away, but we have now hit the big red button and failed the business over. So we're running inside AWS, but there is potentially another copy of that running on premises. Now, this could be a giant problem if we didn't have site recovery, because cleaning this up would be a mess. The reality is it really would be. But if we come in and take another look at site recovery, we can see that site recovery is just hitting us over the top of the head because it's aware of this problem, right? Recovery required. Run recovery again. There's no ambiguity in there, right? So we're just going to go ahead and listen to the software in this instance. We'll come in and we'll run recovery again. You'll notice it doesn't ask me any other questions. It's because it knows that it's trying to finish a previous run. We'll go through and just acknowledge this. And now the system's going to go through an idempotent cleanup where it re-executes any tasks that previously had failed and skips over anything that succeeded. This is going to go ahead and shut down those virtual machines that are running inside that source site. It'll go ahead and prepare the source site so that we can reverse replication. Now that we've run that a second time, we can see that we've got recovery complete. We are now good to go. I'm just going to go ahead and flip this replication environment, acknowledging that this is a permanent activity. And I'm going to now establish a online replication protection relationship that is running from my cloud-hosted VMware Cloud and AWS SDDC back on premises to that New York data center, right? So with, what was that, 6 clicks, we failed over, cleaned up the failover, and then reverse protection so that we are ready to fail back if we so need to. Yes?
So the SRM as a service, does it offer the more or less the complete selections you'd get with the on-prem SRM version? So what I'm getting at is if you have custom scripts or anything like that that need to be executed, those are configurable?
Yeah, the only kind of exception or thing to kind of think about there, depending on what version of SRM you're familiar with, the scripts don't run on the SRM server. The scripts run inside the virtual machine. Right. That's why we use a Bastion Photon VM. We just throw a script in there. It's nice and easy to get in and out. It's not a problem. But yes, the only thing that we don't support today, again, are those storage replication adapters. So if you're using storage-based replication with SRM today, you're not going to be able to use storage-based replication with VMware Cloud tomorrow. But that is something that we're talking to the storage vendors. We want to figure out if there's a way we can light that up.
Can I ask a question?
Sure.
Just an easy one, hopefully. So if customers fail over to VMware on AWS, how many of them actually fail back?
Well, that's a great question. It depends on why they chose to use the service, right? If it's a disaster recovery, then the business has optimized to run permanently on premises. And the reality is, like if we look at the cost, if you're going to have an application up and running for 5 or 6 years, it will always be cheaper for you to run that in your data center than mine. And it'll be ultimately cheaper to run it in someone else's than Amazon's, right? So we need to control that. But it isn't necessarily as cut and dry and or complicated from that aspect. Yeah. Okay, so very quickly I'd like to run through the rest of this. Just let's address that, right? What would that look like? So in this case, we failed over, we're good to go. We can see our workloads running up in the cloud. But at this point, we've restored our source site. We fixed it. So we should be able to fail back, right? Yeah, totally. Both sides are VMware. We didn't do a VM convert, right? We didn't have to re-platform to get this thing powered back on. It's the same exact files. It's the same file format. It's the same exact technology. But before I do that, though, I'm going to go ahead and execute a test because I want to make sure that this failover is going to actually work and I can get that data back non-disruptively. And the test just allows me to increase my confidence that this is going to actually succeed. Because it runs through the same exact steps that we use in an actual failover, with 2 exceptions. The first being that we're going to connect these virtual machines to a bubble network so they can't actually get out to the world, right? And the second is that you can see here that we create these writable storage snapshots. We do that because if we come in here and take a look, we can see that all these VMs are powered on, right? But under the covers, we're still replicating the data from that protected site up into the recovery site, right? So we don't break replication to test whether or not failovers are working. We continue to protect the site even when we're in the middle of a test. Now that we've validated that the test has worked, it looks like our failover plan is working as expected. We can go ahead and we'll just quickly clean this up. Powering off those virtual machines and then deleting all those writable snapshots that we used temporarily, and now we're good to fail back. I'm just going to acknowledge that this is a permanent activity. This is going to temporarily bring everything down, and then we're going to hit go. And what we do is we go through, we synchronize the storage, get everything up to date, then we go through, we power everything down, we synchronize the storage one more time to ensure that we have all the transactions, we've lost absolutely nothing, and then we execute the failover again. Now in this case, that same VM is sitting here inside this priority one. This time it's protected, it's back on premises inside the customer SDDC, and when we get back into Virtual Center, we'll see that we're actually scaling the SDDC down while we're in the middle of a failover, because we no longer need those resources, so why continue to pay for them? And this gets to your point, why would a customer fail back? Because their servers are cheaper than mine. right? So if they can get fewer of mine, that's going to allow them to lower their cost. Now we'll quickly reprotect because we've already needed to use this once today. So let's make sure that it's available in case we need to use it a second time. And this will get us back to our starting point where we are protected across the board.
So Glenn,
Yes.
in this example, this is vSphere recovery, replication, vSAT, and everything else. But you mentioned that there's managed data stores coming or in development. When those come along, would we be able to use the storage adapters and stuff that you have in SRA?
Yeah, so that's why I wanted to get that little information out there. It's not going to be the SRAs you have today. We don't allow VIBs. We don't allow vCenter add-ons. It's one of the exceptions to the VMware Cloud and AWS service, right? Because we manage the virtual center instance, and we're actually running earlier versions than what you have on premises. That's why we have these exceptions. There's no way for us to catch whether or not we'd have a compatibility challenge. We are working with the storage vendors to figure out a way that we can light that back up, because we get it, right? Customers that the same challenge that we have with 15-minute replication intervals, you see on the other end when you start talking about how are you going to replicate a petabyte, right?
Yeah.
At that point, you need a different
Maybe metro cluster type stuff or
something like that, exactly.
synchronous rep.
So yeah, let me, and this will just go ahead and continue to scale back down to our 3 points, but I'm going to close that. Just very quickly close this out and get us back. So again, built on a proven solution. This is the technology you already know. It's Site Recovery Manager, only delivered as a service so that you don't have to worry about 60% of the problem space. Lets you focus exclusively on the disaster recovery capabilities that you actually need to control and are responsible for. The only thing I didn't show in the demo that I want to verbally touch on is our detailed reporting, because a lot of the times when you have that executive conversation about, well, we need disaster recovery, technically if that pipe burst, we'd be out of business. When you get executive buy-in on getting disaster recovery established, they very quickly want to see where that money's going, and they want to see that you tested. They want to see that it's available, and we've got all those reports baked in to make that easy from an operations perspective to deliver that data as required. Yes?
Quick question. If I was trying to fail over a multi-tiered app that had certain requirements for startup orders and different things like that, how would this solve that? And
So we've got those 5 groups, right? So you take, as long as you don't have more than 5 tiers to your app, we'd simply just put them inside our power on groups and sequence within there. If we wanted to, though, we could sequence inside the power on group and just do a dependency on tools, or we could even do something like put it inside a VApp and lock the power on sequence inside the VApp and just fail the VApp over on its own. So lots of options on how to solve that option.
Nice.
Last thing, and then I'm going to get down and free up for the next presenter. One thing that is different with this, because traditionally if you're used to Site Recovery Manager, before you can upgrade your on-premises or your protection site, you've got to upgrade your recovery site, right? There's a hard linkage between those 2 dependencies. This, of course, is a challenge since we're constantly patching the cloud. There's no way that you're going to patch on-premises as fast as we patch the cloud. So we needed to break that dependency. And we did just that. As of version 8.1, SRM and Site Recovery, which is based on that version, now has version-independent API support so that we can go ahead and patch both of those sides independent of one another, and we're not going to break the replication relationship. Okay? And with that, thank you very much. I hope you guys enjoyed this.